as humanity cast an ever-wide net across the cosmos, capturing evidence of thousands of planets. An ancient question haunts us. How did all this begin? Some may say the odds of life existing elsewhere are far greater than it not existing at all. Others may argue life is special and it only exists in this random planet, orbiting an average-sized star at the edge of not-so-special galaxy, existing for no apparent reason. Despite our ignorance, we all agree that finding life out there, even how minuscule it might be, will be one of, if not the greatest moment in the history of our civilization. Let's hope we stick around to see the day. Till date, we have found concrete proof of life in only one planet, Earth. We're still searching for others, and with some luck someday, we may find them. Still, there remain some unanswered questions. One of them being, what are the requirements for life? With a sample size of one, we wouldn't really have a lot to start with, but we can make some educated guesses. According to a paper written by renowned scientist Shigenori Maruyama, there are 9 requirements for the emergence of life. Let's talk about some of them. For prebiotic life to begin, a powerful energy source is required. Energy from sun alone is not enough to break down inorganic compounds such as nitrogen, carbon dioxide, and water and convert them into complex organic molecules. A supply of major elements is another condition for the formation of life, as most organisms on Earth are made of carbon, hydrogen, oxygen, and nitrogen. The early Earth crust, along with the atmosphere and ocean, can supply this, as well as the elements that form the building blocks of organic compound. There must also be a ready supply of the nutrients that sustain life. The nutrient source on early hidden Earth would have been the rocks on the Earth's surface, which were rich in iron and phosphorus as well as rarer elements like potassium and uranium. For life to begin, water must be clean and non-toxic. The early oceans were highly acidic and very salty, and life would not have emerged nor survived here. This suggests that life would have formed in a watery environment on land, such as a pool or wetland. A cycle between day and night is another vital condition for the birth of life. Day-night cycles allow variation in temperature, with low and high temperature driving different types of reactions and encouraging self-replication of DNA sequence. These were some requirements which we think must be present for life to start anywhere. But this doesn't answer our question, how does life begin? There are several theories, but for the purpose of our video, we'll discuss theories categorized by David and Mackay. It's useful to divide theories for the origin of life on Earth into 2 main categories, depending on whether life originated independently on a planet or was carried to the planet from somewhere else. The latter category, usually called panspermia. Neighbors proposed that life could be carried on dust between stars, and others have suggested rocks could travel between star systems. If such dust grains or rocks were incorporated into the preplanetary nebula, then every planet and moon that formed would be infected with life. Theories for the origin of life that propose that life on Earth began on Earth are labeled as terrestrial and could apply to suitable exoplanets as well. A key question for life on exoplanets is how long the habitable conditions, liquid water, must persist for life to begin. Simulation of the Earth's formation suggests that habitable conditions were present no sooner than 3.9 billion years ago, and the earliest indications of possible life on Earth are within 3.4 and 3.8 billion years ago, suggesting that 100 to 500 million years were required for primitive life to form on Earth. There are billions of stars and trillions of planets in our galaxy alone. Even if a small fraction of them harvest life, we were looking at millions of life forms. They are for now way out of our reach. As it's not feasible to look at every single one of those planets in details, we need to prioritize. A well-known list of data needed to determine the likely abundance of life-bearing planets, though highly conjectural, is known as the Drake equation. Put forward in 1961 by astronomer Frank Drake, the list remains mostly blank. It begins with the rate of star formation in the galaxy and the fraction of stars that have planets, leading step by step through the portion of planets that supports life, and most speculatively, to the existence and durability of detectable technological civilizations. We'll discuss Drake equation in a future video. As you see in our solar system, most planets don't have life in them. Earth seems to be the exception here. Analyzing the characteristic of our solar system, scientists use the term habitable zone in an effort to rationalize our uniqueness. In our solar system, Earth sits comfortably inside the Sun's habitable zone. Small rocky planets like ours that orbit other stars are too far away to determine whether they have atmosphere, at least using present-day technology. Over the past quarter century, thousands of exoplanets have been confirmed in the Milky Way galaxy that likely holds trillions. Thousands more will come in light in the years ahead. Tools like Habitable Zone will help planet hunters sort through these growing ranks to pick the most likely candidates for supporting life. Still, we might need something beyond the habitable zone concept for more extreme cases. It don't help much, for instance, with weird life as we don't know it. Living things on other planets might use vastly different chemistry and molecular compounds, or even a solvent other than water. Life on planets around other stars also might be hidden in subsurface ocean encased in ice, invisible even to our most powerful space telescope. Moons of Jupiter and Saturn are known to harbor such oceans, some revealing through remote sensing at least a few of the characteristics we expect for habitable planets. Still, the habitable zone is a good start, a way to zero in on signs of life made familiar by our fellow organisms here on planet Earth. Renowned scientist Gopaparapu said, "It's not a question of if, it's a question of when we find life on other planets. I'm sure in my lifetime, in our lifetime, we'll know if there is life on other worlds."